Hello everyone. Now our topic is elimination of left recursion. So what is meant by recursion first? A function calling by itself is called as recursion. We know that. If a function we can call by itself, then it is called as recursion. Okay. Here in our subject, recursion is of two types. Recursion can be classified into two types. What are those two types? Left recursion or right recursion. If the grammar is, this recursion is related to grammar. Okay, context free grammar. Okay, so if the grammar is in this form, that is A is going to produce A alpha or beta. If the grammar is in this form, then we can say that this grammar or this production rule is in left recursion. How can you say that? Here the leftmost symbol and here the first symbol of right side, that is this one. If these two will be same, then we can say that that grammar or the production is in left recursion. Okay, so now we have to eliminate this left recursion. How can we eliminate this left recursion? So there are two production rules out there, replacement of this production rule. So what are those two production rules? A is going to produce beta A dash is going to produce alpha A dash or epsilon. Okay, we know that. What is meant by A dash here? These are the non-terminals. Then what is here beta and alpha? This beta, alpha and beta, it may be the non-terminal. We know that in context-free grammar, non-terminals can be represented as V. Non-terminals can be represented as V and terminals can be represented as T. Okay, so here alpha and beta are nothing but it may be the non-terminal or it may be the terminal or it may be the combination of both, that is union here. Okay, combination of both, and this alpha beta can be occurrences more number of times also, that is this star indicates. Okay, if alpha beta can be occurred more number of times, that is star indicates. Okay, alpha beta nothing but it may be the non-terminal or terminal or both, and it may be occurred one or more times, that means a star. Okay, so now I will tell with by taking a C code as an example, a small bit, a short sequence of C code. Okay, that is this example. So what is here? A is one function here, and in this A you are again calling A dash, A function. So what is this code related to? Recursion, right? Okay, in the function you are calling the same function again, so that is called as recursion. Okay, so here now coming to left recursion అనే పాయింట్ నేను ఈ కోడ్ ఎగ్జాంపుల్గా తీసుకొని చెప్తాను చూడండి. ఎందుకు మనకు ప్రాబ్లం అవుతూ ఉంది, ఎందుకు లెఫ్ట్ రికర్షన్ అనేది మనకు ప్రాబ్లం అవుతూ ఉంది అంటే ఇక్కడ చూడండి. ఇప్పుడు నేను ఒక ఫంక్షన్ ఇలా స్టార్ట్ చేశానండి. స్టార్ట్ చేసిన వెంటనే ఇక్కడ ఏముంది చూడండి, లెఫ్ట్ రికర్షన్ ఇలా ఉంటేనే కదా ఆ గ్రామర్ లెఫ్ట్ రికర్షన్లో ఉంది అని మనం అంటాము. సో ఇక్కడ ఏ ఆల్ఫా అని ఉంది కదా మనకి ఇక్కడ. సో ఫస్ట్ ఏ ఉంది. A is what we have taken here. A is function. So here also A is there. So A we are going to write it. After that alpha beta are there. Alpha beta. So function is closed. Okay. So first A function మనం కాల్ చేసి ఏ ఫంక్షన్కి బాడీ మనం ఎగ్జిక్యూట్ చేసేటప్పుడు ఫస్ట్ బాడీ లోపలికి వచ్చినప్పుడు ఇక్కడ ఫస్ట్ ఏముందండి? సో అగైన్ ఫంక్షనే ఉంది, సేమ్ ఫంక్షనే ఉంది. సో this is the example for recursion. So you have to call again a function. So the control will goes to here, again comes to body of this function, then again it calls the same function. Like that the control is iterating infinite times. ఓకే దెన్ ఆల్ఫా బీటా ఎప్పుడు ఎగ్జిక్యూట్ అవుతాయి ఇంకా మనకి ఈ టూ నో నెవర్ ఎగ్జిక్యూట్ సో దట్ ఈస్ ద ప్రాబ్లమ్ ఆఫ్ లెఫ్ట్ రికర్షన్ హియర్ సో లెఫ్ట్ రికర్షన్ అనే దాన్ని గ్రామర్గా కాకోకుండా మనం ఇక్కడ ఒక సి కోడ్ ఎగ్జాంపుల్గా చెప్పుకోవాలి అంటే ఇక్కడ ఇది ప్రాబ్లం ఓకేనా దట్స్ వై వీ హ్యావ్ టు ఎలిమినేట్ ద లెఫ్ట్ రికర్షన్ బై యూజింగ్ దీస్ టూ ప్రొడక్షన్స్ యూ కెన్ ఎలిమినేట్ దిస్ లెఫ్ట్ రికర్షన్ okay and you know that parsing are of two types. What are those two types? Top down parsing and bottom up parsing. Two types are there and left recursion is problem with top down parsing. If you are going to performing top down parsing, then if the grammar is in left recursion, then that is the problem to top down parsing. So what you have to do? Left recursion you have to eliminate in top down parsing, but in bottom up parsing there is no problem in bottom up parsing, but in top down parsing that is the problem. You have to eliminate the left recursion. If you are performing the top down parsing, then you have to eliminate the left recursion. Okay, that is the small introduction, a brief introduction about this elimination of left recursion. Okay, now I will explain with one example. What is the example here? This is the example. So what is the example? Eliminate left recursion in, what is that? E is going to producing E plus T or T. T is going to producing T star F or F. F is going to producing parenthesized E or ID. This is one grammar here. This is the grammar. Now you have to eliminate the left. If you observed any left recursion in first production, second production or third production, we have to eliminate it. That is our question. Okay, so first I already said that if the grammar is in this form, A is going to produce A alpha or beta, then that is in left recursion, right? Left recursion. So how can you eliminate it? By using these two productions. Previously I said. Okay, so now coming to our problem, what is the first production here? E is going to producing E plus T or T. Now you have to check that this production is in left recursion or not. Now see that here the left symbol and here first right symbol both are same, right? Both are same, so definitely it is in left recursion. Okay, how can you eliminate? So this production you have to replace with two production rules, these two production rules. Okay, so now first we have to identify what is meant by A in this production, what is meant by alpha in this production, what is meant by beta in this production. Now what is meant by A here? E is A here. Okay, now here also A is there, same, A is A here. What is alpha here? Plus T is alpha. Now what is meant by beta here? T is the beta. Okay, now it is in left recursion, right? Now we have to replace this production with two production rules. What are those? So first A means what here? So A means here E is going to produce beta means what here? T and A dash means A means E, A dash means E dash. So first production is over. Now second one is A dash means what here? A dash means E dash, and alpha, what is meant by alpha here? Plus T. So plus T. After that what is meant by A dash here? E dash or epsilon. So we eliminate the left recursion in this production by using these two rules. Okay, first one is over. Now second one is what here? T is going to produce T star F or F, that is this one. Okay, now we have to check that this production is in left recursion or not. Yes, of course it is in left recursion. How can you identify? Here the left hand side non-terminal is equals to first right hand side non-terminal. Both are same here. Then it is in left recursion. So you have to identify A, what is alpha, what is the beta here. So here T is A, here also T is A. Alpha means star F can become as alpha. So what is beta here? F. F is the beta. You have to replace this entire production with these two rules. These two rules, like by applying this formula. By applying these two productions. Okay. So A. What is meant by A here? T. T is going to produce. What is meant by beta? Beta means F. F. Okay. A dash means T dash. Now next one is A dash means T dash is going to produce alpha. Alpha means what here? Star F. So star F. Okay. Next one is what here? A dash. A dash means T dash or epsilon or epsilon. So we replaced this left recursion production rule with these two productions. Now first one is over, second one is over. Now coming to third one, that is F is going to producing parenthesized E or ID. Okay. Now you have to check out that whether this grammar, this production is in left recursion or not. No, it is not in left recursion. Left recursion lo లేదు ఇది. ఎందుకు? Because here the leftmost non-terminal is not equals to rightmost symbol non-terminal. Okay. So now we can say that it is not in left recursion. So finally, how you are going to conclude it? So after eliminating the left recursion, so these three are over, right? So it is not in left recursion. It is there. It is there. You replaced these two productions with these two. Now finally you have to write all the four productions at a single at one place. Okay. So what is there here? He is going to producing T dash. Next one is this one, and next one is this one, and this one, and at last what is there? F is going to producing parenthesized E or ID. This is the perfect grammar after eliminating the left recursion. After eliminating the left recursion. So what are these productions? So these two and these two and this single one you are writing at one place. Okay. This is the grammar with the replacement of this grammar. Okay. Thank you.